Hello everybody, members of Sustainable Labs Canada, and welcome to the Sustainable Labs Canada webinar series. The webinar will begin shortly, but just before we begin, we'd just like to remind you that questions will be answered at the end of the webinar. If you do have a question during the presentation, we encourage you to enter them in the Q&A button that you can see at the base of your screen. This will save the question in a place where we can review and address them at the end. Please note this webinar is also being recorded and will be posted on the SLCAN website for your reference. So this month we're absolutely delighted to present Peter Mylia, who will be presenting a data-driven approach to healthy and safe lab management. Peter is the VP of Sales for Aircuity and has over 30 years of sales management experience in the building, healthcare and laboratory control sector. Peter spent the last 10 years at Phoenix Controls in various positions of sales management, including VP of Global Sales with responsibility for all sales activities. During this time and before, at various positions, he's held VP of Sales and Marketing positions, and has achieved great success working through independent distribution channels to provide building, healthcare and laboratory control solutions to their customers. He holds a Bachelor of Science in Mechanical Engineering from the University of Akron. And with that, I'd like to hand over to Pete.
Thank you very much, Dawn. I'd also like to add that I've been with Aircuity since it started in the year 2000. So I've been there for the last 21 years. Before that, I was with Phoenix Controls. Well, I appreciate the opportunity to speak with the SLCAN attendees, and I'm very pleased to have this opportunity. So we'll dive right in. And basically, there we go. Sorry. This is the agenda today, a little bit about Aircuity, but more about the different insights of the data management for laboratories itself. We'd like to then get into the future of healthy and safe sustainable labs at the end. And of course, it should be 10 or 15 minutes at least for additional questions. So from the standpoint of Aircuity today, we've been 20 years, as I said, it's 21 now. And we've got, closing into about 1,000 different project opportunities across 17 countries. And about half of our projects are in, or a little more than half, are in critical environments like laboratories, vivariums, etc. And that's where we'll spend the majority of our focus today. This is just a little drawing of the system itself. We actually have an animation on our website that shows it operating. But the key things I like to point out here is that we start there on the top left, and what we're looking at is either outside air or supply air to determine what's coming into the laboratory or the various rooms in the building. With that, then we take a sample out of the lab, as you see, through a duct probe out of the general exhaust, and then we send that sample through a router back to the sensor suite that you see there. So the sensors are not in the room, the sensors are here in the sensor suite, and that allows us to multiplex those sensors and do approximately 28 or 29 labs plus one supply reference per sensor suite. So this gives us the opportunity to use much higher grade sensors and provide an excellent way to keep them calibrated, just having one set of sensors in there. And we'll just show the sensors in a few minutes. But then through our what we call IMS, we take that information and we send it to the lab control, and they do the control within the laboratory. So you're not buying any other lab system. We integrate with all different brands. And the key is we're just making that system be more efficient by looking at the air quality and using that as a way to set the minimum ventilation rate and then increase the ventilation rate when things happen. And that's some of the data that we'll share with you. So that information has also gone out over the cloud, and now it's available for all people that have a password for that particular account. So the reason this is important is that The information does go to the building management system, but not everybody and many people do not have access to that for information. People like environmental health and safety folks, departmental managers, and even researchers themselves can see what the air quality and what's going on in their laboratory. So the key platform features are the fact that we can provide very accurate measurement. Because we have the same sensor looking at the outdoor supply air versus what's happening in the room, any increase or decrease in what's going on in that room is actually monitored accurately, so that you don't have to worry about the differential of sensors between the two spots. So as I mentioned, we're able to deploy high grade lab quality sensors because they are much more expensive than just a typical temperature or humidity or even a CO2 sensor. And you need those sensors to be able to multiplex it over that large footprint. Active control means that we now select that signal, or the control system selects that signal to have active control based on actual conditions in that room or at the air handler. Meaning, instead of just having one ventilation rate, you can provide the ventilation rate that is best suited for what's going on in the lab itself. Of course, you still have the hood that drives the supply in the room as well, because as people raise or lower their sashes, more air is required there. And the same thing with temperature, so that you have a temperature input that tells you whether how much air you need to keep the temperature correct in the laboratory space itself. So what happens basically is that room controller that's provided by the lab control company looks at all three of those inputs and makes the choice that the higher one gets the appropriate amount of air. So if you need more air because they open the hood, it's going to send the supply signal to bring more air in. Or if the hoods are closed and you need more air because somebody left something out on a bench top and they're creating an air quality event, then you get more ventilation air to satisfy that. But what we're going to really focus on is the reporting. So the individual reporting by building and room and parameter is really provides the insight on what's going on in the lab. So you can make decisions, and the participants, or even the environmental health and safety, the people in the lab, can see what is happening and have information that's very important. So these are just available sensors. In the lab, you definitely provide the two different types of TVOC sensors, also a laser-based particle counter. Sometimes humidity is important, it may not be. CO2 often isn't used in the lab because of the fact you're bringing in 100% outside air. So the thing that keeps it accurate is the fact that every 6 months, those sensors are replaced with newly calibrated sensors from the sensor depot at Aircuity. So those existing sensors are sent back and replaced with newly calibrated sensors that are cleaned and replace various components, and then are calibrated over multiple values. So then that information goes to it can go to a laptop. B, you can access the information with any type of tablet. And now we've got introducing a phone app that at least can get general information about the air quality in the space. So all this information is available over the web, in the cloud, password protected, encrypted, etc. And that's the analytics that we want to talk about, and using data to help manage what's going on in the lab. Okay. So the key insight section was really talking about the number one thing is managing efficiency. It's still critically important to provide an energy efficient lab. Now we had that's what the driver was for the vast majority of our over 350 installations across the world in labs, was energy savings. And the fact that, as you can see here, this particular lab is saving about $90,000 a year. It's not a real big lab, but that's still pretty significant. But the other point is that a lot of the drivers have also, and we'll talk about, providing safe air quality, good air quality in the lab for the researchers to be working in as well. So it's a combination of providing a more efficient lab and providing more information to people like environmental health and safety and the department managers on what's going on in the lab and as well. But we'll start with the energy efficiency. And this is an example of a screen on the dashboard that shows that they're getting about 72% of the savings that was expected. It wasn't so much that it was expected. It really tells you that if you had the lab at a minimum all the time, which is never going to happen, it'd be 100%. It'd be the lowest you can have. Here, because of the fact you need more air to satisfy the hoods and temperatures, we're saving about 72% of that process. And what you see on the trend graph is that on the very top is where you would have been before air acuity. And then you see the actual airflow is in green, and you see the design minimum. The next line down here would be as if everything was it's almost as if the lab wasn't being occupied and didn't have people in it. So this is a pretty good depiction when you see it. But the other way to use this data is taking a look at this lab. So this lab had a fair amount of savings, but it was a bigger application, had 54 rooms in it, but it was only getting 56%. And what you quickly look at on the graph is here in about mid-December, that this supply went way above even where we were previously. And then it came down a little, but for a good 2 or 3 months, it had increased significantly. So by looking at this data, you can say, let's figure out, why is this happening? What's going on, that the fact that we were down here at this level, and if this was a live dashboard, you could put your cursor here and see exactly what the flow rates were. But what happened here in mid-December that could have derailed our good energy savings? So what it is, one of the things that we do is rank SASH behavior in the entire building and in the entire campus. So if you have multiple buildings, as an example, on the system. So this enables you again to say, there could be 3 reasons technically that you're above that level that you were for such a long time. Are people leaving their hoods open for extended periods of time? Are there actually a lot of events that are driving higher ventilation rates that we're picking up? Or is there all of a sudden a higher thermal load in those spaces? So what you see here is that a lot of what's happening with labs is that it takes a behavioral change for people to become aware when they leave the sash open, it wastes a lot of energy. And what helps you to let them know is that, guess what? They know my sash behavior. In other words, here you see in this particular room, and this was that lab that went way high, the exact sash position, and then the supply that's tracking it, this particular lab was at 100%. So that meant, at 100% of the sash open, and really the threshold should be somewhere around 25%, unless they're opening and setting up the lab. Then you should have it about 25%, and you're working under the sash itself. So this type of information, and this is another way that you get to that information, is that here is a actual depiction of all of the labs, and obviously you hit more and you get more on the screen. But what happened here is you want to say, well, there's 24% that aren't being closed, and they can tell how much they're not in use. 71%. That's pretty common, that people aren't in front of their hoods 100% of the time all day long, and then you've got unoccupied hours. And there was only about 4% that were kind of in a normal mode. So what this ranks, as you see, is here was about 7 or 8 labs that were 100% open, the duration for 7 days. and it showed the flow that they had. So right away, what this allows environmental health and safety, or it could be facilities because you're not saving the energy, is to take this information and go to these rooms and let them know, hey, when you're not at the hood, when you're not using the hood, you close the sash. Okay. So the savings, again, you can rank the whole building for overventilation. Now, sometimes that overventilation may be not that they're just leaving the hood 100% open all the time, but there could be other things. They could be leaving a jar of chemicals open on a bench top, and you're always having to bring in more air because the air QD system is picking this up. So this you see that actually has the high air change rates or the estimated savings. This is ranked by estimated savings. So here's two labs that they're not saving anything. And as you go farther down, you see it gets better. So getting this type of information in a dashboard, and what you see here is dashboards, is great because you can take a whole look at the building and just hone in on the labs that are problematic. So what you do here, what you see here is, again, by room, what's driving, what are the drivers? So these rooms aren't being driven by demand control ventilation. They're actually third of the time fume hoods, third of the time are thermal. So you basically try to, again, hone in on this information to get more data related. That's the energy relationship. Now, here's another look at identifying the whole building for environmental health and safety. Now, this looks at the specific parameters. So we're going to look at particles here, and the particles. You look to the dashboard here, and you see that a particular room. This is ranked by the max value, but what I also like to rank this by is the number of occurrences. So this gives you an example that you've got 4 rooms that are, this is during a week's time, are above 19. You see there's 20, then 5 isn't too bad, but 19, 23, and 27. So events do happen. So the fact that there's 3 or 4 or even maybe 5, you don't focus on those, but you certainly want to go to room 250 and say, you've got 20 times during the last week with a maximum value that you were exceeding, the threshold for particles. What were you doing? And you actually can click on that particular room and then get that room through a graph that shows when exactly, how high it went, and what part of the day, time of day, and etc. So again, information is powerful to use. So here's an example. When you click on that room, what you see here is you see the threshold, and you see that exactly when it happens, what time of the day. This was in October, and when you click on that when it's a live screen, it's going to tell you the exact time, and you see that the fact that they go high and they come back down low, and that's because the air QD system's increasing the ventilation once it gets above that threshold and brings it back down. But the fact of the matter is, this in this period of time, which is you see that there's 3 to 6 or 7 times that it went over that threshold, and that's too much. You got to figure out what happens. Go to the room, fix the problem. The solution to pollution isn't really dilution, it's source control. Meaning pollution, ventilation rate will take care of it when it happens if you're using air QD, because it's going to pick it up and it's going to go higher. But the real issue is you want to hone in on when it's happening, if it's happening a lot, and determine what's going on. Maybe they're doing something every hour that should be out on a bench top, that should be either in the hood or maybe under a snorkel or a ventilation device. And then you're gonna, that would help take care of the problem. Here's another one showing the 2 different types. This is a TVOC. What you see below is you just see that the supply flow is going up, sometimes, most of the time, in conjunction with the event, but it might go up just because somebody's opening the hoods too. So you see sometimes here this is up pretty high, but the event's not that high. So this is probably driven by not just that event, but people now are at the hood and they're getting a higher supply. But you see, these two coincide with that, and many of these supply increases like these are due to the fact that they're having high PID events. So again, this would be a chemical event that's happening fairly regularly that you want to go talk to the researcher or student or whoever might be in there, that they're doing something at these specific times. A matter of fact, what's interesting here is if you look at this, this happens about the same time of the day. If you look here, this is about 11, 10 o'clock or right here. But you look at this, it's right after the noon hour. Same thing here, same thing here, same thing here. So there's something specific. Who knows? Maybe they're cooking lunch in the room. I don't know if that's the case, but it's something's happening at noon every day that's throwing the VOCs high and the supply concurrently. So the neat part about this now is that, we always had it available on a tablet, and now we're moving it to an iPhone as well. And the iPhone is mainly for a lot of times the people themselves. And this is also being used a lot because we're also not just used in labs, but we're used in classroom spaces or office buildings where the indoor air quality is a big issue today, and they want to know that the air quality in their space is good. So being able to have it be proactively sent to end users, that's the decision of the building owner or of the university, if it's a university or researcher, or in the case of buildings, the building owner. So the last section I want to kind of get into is the health and safety of it. So we've talked a lot. A lot of the health and safety comes from the fact that the fact that we react when there are high events. If we're not in there and you saw those spikes going above those levels, then they're in that air, and they may be providing more air changes because they don't have air acuity. But like I said, the real solution isn't to be in a bad environment and hope that enough ventilation takes care of it. It's to figure out what's causing the bad environment, and let's address it. So this is just one of the buildings. It was actually a project of the year, and this particular 22-story building, had a significant rebate as well, and it had both labs and vivariums. And so here's some of the information there. That here, this can exactly show what I was talking about. Is here in September, they had an event, and right away you see the air acuity supply, air acuity telling the supply to track that. So you tend to see these are the benefits of basically using a dynamic approach to air changes, which means instead of picking a fixed number, picking a dynamic number that's gonna go higher when you need it, but not overventilate it when you don't. That's why you saw in this particular job there was a terrific payback. This is Georgetown University, same type of thing. This is a PID sensor. You see that on this particular room, you see it going above the levels. Here's where it is all the time. Now, this isn't an issue because it's only one event. It's just here to show you that, here's where the system reacts with the high supply, keeps it up there long enough to bring this back down. And then, here was a little small blurb. You see this right here too, reacting. But, these are the types, this isn't where somebody's going to spend a lot of time investigating because it was just one event, but this is just on one particular day as well. So, the future of research, what we see is the fact that universities and private companies and pharmas are still investing heavily in research. And one of the things that's happening with research is the fact that it's not all about energy savings. The Well Building Institute has come along and they've talked about, for a long time, we've taken care of labs and they're critical spaces, and make sure that the air quality is good in the lab. And it's really from a safety standpoint. But what also happens is that, as you see here, this is from Well, is that even from a research mode, if you get out of that lab and let's say people are in support space, it's just important for that support space to have good air quality, because there's all these studies that have proven that people are more engaged, better use of time, lower absentee system, all the way up to the fact that people do better work in better environments. So in these types of facilities, the fact is that we have gotten involved and said, we've been doing critical spaces for so long, but now a lot of it driven by a lot of it driven more recently by the pandemic, is the fact that air quality is important in all spaces. Regular classrooms are now critical spaces. Not just the labs in the buildings, but what about the classrooms or the offices where people are doing their work? Is the fact of the matter is that you want to have and show that you're providing the right amount of outside air there. Now, in those spaces, they don't have events, the kind of events we have in labs. But the fact is that we've proven, and the studies have proven, more dilution ventilation rate, better filtration, lower particle levels. With cleaning events, there's higher TVOCs. It's not as significant as the lab, but on the same token, if you think about a lab, we're bringing in a lot more air all the time. The ventilation rate in a lab is many times more than you're bringing into office space. And what's happened in a lot of those office spaces is we've choked back air a lot because of energy. So here's an example. CO2, as I said, in a lab, it's not as critical because we're always bringing in at least 2, 3, 4 air changes or more. But in a space, an office or a classroom space where the researchers are, we want to look at, the outside air. Remember me telling you, you want to look at what's happening outside or on the supply side and relate it to what's happening in the space. So here you see, the fact is that the reason you want to look at the outdoor air, not so much for labs, because it's 100%, you look at the supply air after it's filtered. But the outside air is important for the non-lab spaces, because you can't just say that here's the CO2 level outside, because right here you see that it varies from maybe 425 to 525. It depends on the time of the day. It depends on time of the year, what's going on outside. So you really need to measure what's going on inside. Then you can see on the supply side, you can see, that it becomes a little bit more, it's filtered, it's treated a little bit more. And then you want to look at the return air. And the return air, because again, now there's CO2 levels, there's people that provide, they breathe in and give off CO2 in the space. And here you see the space itself, same type of thing. And so you want to maintain a certain level of CO2, and it varies. It's not going to be as tightly run as picking up one number. But here you see that it's really kind of between 400 and 500. But you might look at the fact that this gold guy is much higher, and maybe something's going on, that more ventilation air is needed there. Particles are another piece, that you look at, again, from an air handler side, because stuff happens outside, In other words, this period from the 24th to the 27th, all 3 air handlers went fairly high compared to where it had been and where it ends up going. What easily could have been happening is there's construction outside, there's something going outside, wind blowing it. I mean, when we had, the fires out on the West Coast, you could see how bad the outside air got consistently. But here, probably over this 3 or 4 day period, you might have had some construction going on out there. And here you see the return air. This spike is interesting. Again, without delving deeper, this is again the return air on those 5 air handlers. And then you can go back down and look at the rooms itself. So this looks pretty busy because again, what you want to do is you know, if all these guys are pretty good, you want to see if there's a particular room that has a lot of events. You know, this is one event, the green guy here, but you don't see him a lot else. So sometimes things can happen, but what you're looking for is either real high events that stayed high for a while, or somebody that's having a lot of events. Here's RH, relative humidity in the rooms have become very important. There's been a lot of studies now, or one particular, Dr. Taylor's done a lot of studies and published a lot of things about maintaining your relative humidity between 40 and 60. So these are the rooms now in this particular say, and you see they go down pretty low. They go down to 30 because it used to kind of be 30 to 60, but now they've tried to raise it some. Interestingly, yeah, I don't know if this is a weekend without looking back here that it's lower and it increases up here, but you know, here's a trend that sees the humidity going up, you know, above, in this case, 60%. But like I said, when you see these types of things, this gives the whole building, and then you can hone in on something particular that you might want to look at a little bit more. So what we're all about is measurably better environments, okay? So using this type of information, you know, that you can make decisions, and you can see when the building starts or particular rooms start trending high, or you see higher levels of particles or TVOCs or even humidity, is the fact that you want to be able to monitor it and then have it actively controlled. By that I mean, you know, there are these systems out there, not for labs, but for office spaces and classroom spaces that that sometimes can take a look at things with really inexpensive sensors, display them on the web. But what good does that do if you can't integrate it back into the control system? Because what you really want to do is, sure, you want to find out when things happen and when they increase and go out of range, but you also want to have the ability for the building management system or the lab control system to be able to react to those scenarios. And so it's really important that it is actively controlled, say, so that the system, the monitoring system, can integrate right into the lab control or the building system, and based on that information can create a sequence of events to take care of it, or even if you want to alarm it if it's highly critical or if it's above a certain level. And that provides both a safer environment for your researchers and students, and a healthier environment. And as I said, you know, the move towards buildings not just looking at energy efficiency, but also looking at the healthy aspect of the building for the inhabitants. For too long, we just focused on the building itself being energy efficient and meeting some energy requirements. You know, LEED was a driver for that for many years, and LEED's still around and it's very important. But you can have an energy efficient building along with having a safe building. So these are just some of the customers that we've done business with, and I've actually got done a little quicker than I thought I might have, but it's easier when there's no, you don't stop for any questions. But I'd be happy to answer any questions and spend any time, go back and spend any more time on any slides that anybody wants to.
Thank you ever so much, Peter. That's a very interesting and thought-provoking presentation. We've got a number of questions that have come up that you may like to address. There's a couple in terms of air quality systems. Have you actually installed in Canada, and in particular installations in British Columbia?
Yes, we've got a number in British Columbia. We've got, I think, all three universities. We've done work at University of British Columbia, Victoria, and Vancouver. There's about, I think we've got about a half dozen in the British Columbia area. Same in pretty much every province. Probably the most are in Toronto, just because there's more universities and things, but from the Maritimes to British Columbia. We've got numerous installations. Um, let's see, one of the other ones I know that we've got some system at is Simon Fraser University. So we've got things at University of British Columbia, Simon Fraser, and our representative out there is Aqua Air, and Kevin Shelast is I don't know if he's on the board, but I know he's very active in SLCAN, and he can provide a full list of what we've got in British Columbia.
Thank you. There was another question as well. What is the maximum sampling interval permitted per space when utilizing a common sensor suite?
Very good. We have done testing that shows the maximum time to be able to react, and the maximum time we ever allow is 15 minutes. So there's a study that we can share, depending on what area you're at. We can send it to you from our local rep that shows that we did some testing, which actually was some spill testing that spilled 200 milliliters of chemical, and then talked about how long it was for to react to it. So it evaporates for a certain length of time, and then what happens is, because we react and go to such a higher air change rate, we make up for the fact that there's could be a lag before we increase the ventilation air. Now, one thing I always want to point out is that this isn't used for spill control. This is used for events that happen in the lab that nobody leaves the lab for now. If there's a spill, there's a standard operating procedure, which every university and pharma and research facility has, different on each one, but sometimes they have a mushroom switch that you hit on the way out the door to put the lab in a full flow. Sometimes people hit the full flow button on a fume hood monitor. But the point is, spills are something that you've got to react to immediately. But a small event, or like I say, if somebody says a few drops of chemicals or knocks something over and cleans it up, they don't leave the lab. That's what this system is for, those types of events.
Okay, and so following on from that, we've also been asked, can the sensor suite be maintained by site staff, or is it only maintained by Aircuity?
Yeah, first off, it's maintained by the local representative for Aircuity, so you have local support. There is some basic training that can be provided. Normally people have the local representative do the sensor swap every 6 months. But there's some basic training that, the fact is there's not preventive maintenance, so to speak, because the representative is out there every 6 months to swap the sensors and run the other pump, and there's a small filter in there that's replaced. That's the extent of that. But in some cases, every once in a while, if people want to get trained on some aspect of even swapping the sensors out, that can be done, but it's not labor intensive. So most people just let the local representative do it, but we have options for that.
Okay, great. Then we've also got a question. What types of air quality parameters are the sensors recording?
So what they're looking at is TVOCs, which are total volatile organic compounds. And the T means total, which means we don't know if it's ammonia or hexane or what type of volatile organic it is, but it's the total amount. And there's requirements, not requirements, there's standards that are set for TVOCs. And that allows us, the two different types of TVOC sensors, to look at literally hundreds of different chemicals, so that when the composite amount of VOCs is above a certain level, then the signal is sent to the lab control system, in this case, to increase. The other ones are laser-based particle counters. So we look at small particles, 0.3 to 2.5 microns, and those can be out there. It actually picks up smoke if there's a reaction outside there, so that would increase it. or sometimes with biologicals that there could be some particle levels above a certain level in the air, and that's what we look at. Then we do look at CO2. CO2 is, again, not normally looked at in the lab because of the 100% outside air. And we look at humidity. Again, not every lab has humidity, but if we're doing vivariums, the animal spaces, they always want to know the humidity levels in there. And carbon monoxide is the other parameter that we can look for. And we don't always, it's not a real common one that we use, but it's available.
Okay, thank you. And then what is the approximate installation cost per square foot, and what is typical yearly maintenance cost?
Well, what I'd like to do on that is have you talk to the local representative, just because a lot of it installation includes local labor, and the labor costs from the Maritimes to British Columbia is quite different, as is the but so the point is, and normally we don't do a square foot cost. What we would rather do is a per room cost, because when you look at a lab building, you could have a lab building that could have 20 labs in it, or the same square footage could have 40 labs in it. It just depends. The density of labs change it. So square footage in any research is a kind of a tough one to go by, but you usually know the number of spaces. So what I would do is, if you don't know who the local air acuity rep is in your particular area, um, let me know, and we can provide it to you. And what they can do is provide you that type of estimate. And then the maintenance costs are directly related to how many sensor suites and sensors you have. So same type of thing. The maintenance costs for a building, and we have a huge building in Toronto called the UHN Tower that has some like over a dozen sensor suites, and we have other buildings that might have one or two. So the maintenance cost is going to be much less for a one sensor suite job and 28 spaces than a multi-sensor suite job. So same type of thing. You can get an estimated cost from the local rep that gives you a sense of, hey, a one sensor suite job, that could be 28 or 29 rooms. The cost per room is approximately X installed, and the maintenance cost is Y, and they'll be more than happy to provide that information to you.
Thank you. Also, we've got another question. Is there an example or installation monitoring flammable and chemical cabinets? Is this idea an overkill?
What I've seen with cabinets is that, again, we don't look at anything in the exhaust side of a fume hood or a chemical cabinet. We're looking at the actual room that the cabinet may be in. So the fact is that, hopefully that chemical storage cabinet is exhausted separately to the outside. And, but yet whatever could be in there, if it's open to take the chemicals out, that would be, then we would be monitoring the room that it's in, then except and not the specific cabinet itself.
Thank you. We've got another question as well that came through earlier. Are there other types of research buildings that can use the air acuity system?
Yes, the main other research building that we're involved with now, finally in Canada, I say, because some new guidelines for CCAC changed, are the vivariums. Vivariums are, as most of you would know on this call, are the animal holding areas where the animals that are used in research are held. And so we have been doing this in the States and other parts of the world for many years, but just in the last maybe 2 or 3 years, the CCAC changed their standards and allowed you, Canadian facilities or Canadian vivariums, to vary the air change rate like we do in labs. Now, in there, we're looking mainly, particles are a big thing, and we're looking at using the TVOC sensor to look for ammonia. So that's been something that even the CCAC believes that they recommend that even if you're not lowering the air change rate, you ought to be monitoring for the quality of the air for TVOCs and particles and actually CO2 and humidity levels. So that's now a growing opportunity for us in Canada, whereas before and we've done a number of jobs now in Canada. The University of Lethbridge was a really big new construction we did. So now, whereas before you had to run a fixed air change rate, I think between 15 and 20 in the vivarium, now the guidelines allow you to lower it. So vivariums are a big area. The one area I want to caution, there aren't many of them that we don't get involved with, is BL3 or even BL4, which is even tougher. But the BL3 or biological level 3 or 4 laboratories, which house very dangerous chemicals, or those aren't areas that we monitor and do anything with, because those are critical areas that are pretty much sealed in and you're gowned in and have airlocks and things like that. So you're not going to change the ventilation rates in those types of room. But what's considered a BL2 lab, which is just standard chemistry, standard biology type of labs, we do all types.
That's great. Okay. So I don't know if we've got any other questions from the audience. It doesn't look like we have any more. I'd just like to say thank you yet again, Pete. Really, really good presentation. And as you said, information is powerful. I'd just like to remind everybody on the call that they can find a recording of this online on the Sustainable Labs Canada website, slcan.ca, under resources and events. And also next month, on June the 9th, is our next webinar, where John Bell from RWDI and Gordon Robbins from the University of Toronto will be presenting on commissioning for labs and the owner's perspective. So I'm sure that again will be a really interesting presentation. So thank you everybody for attending, and thank you very much, Peter, for giving up your time and providing us with a really interesting presentation.
Thank you very much for allowing me to present to this esteemed audience from Canada. Thank you very much.
Okay, thank you all.
Be
and
safe,
goodbye.
stay healthy.